The synapses, the connections between the nerve cells, are the ultimate key to how a brain develops and how a brain works well. There are many, many disorders that are in some part affected by the changes in the brain, specifically changes in how one nerve cell, one neuron connects to another through the synapse.
The importance of synaptic loss in living people is that of all of the pathologies of Alzheimer's disease, it's the one that's best correlated with function. Before the study, we couldn't measure synaptic loss using PET. We couldn't measure it in living people. We could measure it at autopsy, looking under a microscope.
Now we don't have to wait for death. Now we can image these things in the live human being and being able to assess what's going on in each and everybody's brain. The patient comes into the scan room, they're positioned in the scanner. Our technologists inject the tracer into an intravenous line, into a vein, and then that circulates throughout the body. In this case, we focus just on the head and just on the brain. We can collect that information over time. Sometimes it could be as little as a 10-minute scan, or it could go as long as 2 hours. And then we can use engineering technologies to be able to extract quantitative measures out of that, including synaptic density. We can show those regions that are lost, that are affecting the memory and cognitive losses of those diseases. We found them to be very specific to one primary area in the brain, the hippocampus. It's an area long known to be related to memory.
And also we can use that and as a useful tool to monitor if there's any useful treatment which could alter the synaptic density loss to restore the synaptic function in those Alzheimer's disease patients.
And we're beginning to look for is if we can begin to find drug treatments that will restore these targets, we'll then be able to measure in a live human being synaptogenesis, the increase in synapses. And we have a current study going on with a pharmaceutical company using their drug to be able to evaluate that. And that will be very exciting if we can see that in a live human being to prove that, in fact, we can restore synapses with the appropriate drug treatment.